This is a conversation with Nick from Technical Marine Supplies about lightning protection systems. And I'm going to turn it over to him to let us know a little bit about the system, how it's been working, where it's installed. And then at the end of this, we'll have a Q&A. So Nick, take it away.
Lovely. Well, thank you. So as Captain Dima kindly said, I'm Nick from UK company called TMS. We handle the distribution and supply of a lightning prevention system. And I do choose that word carefully. And we look after all of the boat builders, riggers, installers all the way across Europe and a bit of the Caribbean and South Africa, would you believe? All from our base in Devon in not so sunny England. I do have a slide presentation. I'm really sorry, but I think it's the best way to communicate the technical side. My intention is to give everybody a bit of an overview of how I perceive lightning and how it forms. We're going to look at how it performs differently in different parts of the globe, over land and water. I'll explain the technology to you all, and then we'll look at some of the effects of lightning on stainless steel and aluminium on your rig and rigging itself. Part of our business is we manufacture and represent wire rope manufacturers and rigging manufacturers. So we see it from both sides, preventing lightning, and then we see what happens when you don't. So I will jump on and share my screen now. He says, and here we go. Many screens, apologies, and I'll be right there with you.
Perfect, we can see.
Fantastic, thank you for that. So I'm presenting the technology from Sertec Marine. Sertec is a Paraguayan-based company, and they manufacture a product which they call the CMCE. Can you see my screen okay there?
Yes, we get it.
You can, fantastic. So they're based in Paraguay, and the company's been protecting assets for about 35 years on land. And about 12 years ago, they moved into protecting marine and offshore assets. The device is called a CMCE, which translated from Spanish is a multiple electrical field compensator. And I used the word prevention earlier. We prevent the lightning from forming around the asset, around the vessel. TMS, as I touched on earlier, is a European distributor for marine and offshore products. And we work in various different market sectors, as I say, across Europe, Caribbean, with the catamaran builders in South Africa as well, and wherever we're kind of tasked to go. A few facts about lightning. I find it fascinating. I'm quite passionate about lightning itself. But the actual bolt is only about 1 inch wide. So it just shows kind of intensity of that superheated air when we see that flash. It's 5 times hotter than the surface of the sun, and typically they're 2 to 3 miles, about 45 k in total length. And I will try and translate imperial to metric as much as I can, because I'm conscious we're talking to people from around the world. The most interesting fact, I think, is the mega flash. This was confirmed only last year. It was from 2017, and it was a 515 mile long strike, which clarifies what we say about the bolt from the blue. You can be away from a low pressure storm, completely fine, but up to 500 miles away, you are unfortunately potentially at risk from inducing that strike. And there are about 44 of those every second. So I'd like to lay some facts down really about the lightning. Unfortunately for us, though, we're seeing that lightning strikes at sea are increasing. Just 6-7 years ago, it was 10% of lightning at sea, and now it's up to 50%. And there's we'll look at a few reasons why that is increasing. But we're finding they're more powerful as well when we're over the water. And a lot of this is due to the ion, the atmospheric, the difference of the atmosphere above around the water and the ocean. And then we'll also look at the patterns that we see forming, and we're NASA and the Institute, University of Washington, sorry, were very quick to jump on why that was. So we'll look at that in a second. But essentially, this what we're trying to say, you don't have to be underneath the cloud. You can be arguably 30 to 40 miles away and realistically induce a strike. Very quickly, lightning is an electrical charge. I like to think of it as a magnetic charge, positive and negative. They attract, and I just find it really nice in my mind to understand that attraction when I think of a magnet more than just voltage and current. So the three types of lightning we experience, we have intracloud IC lightning, and that's when we see the flash within a cloud. So that's a cloud shorting out with itself. We have the cloud to cloud, a little bit more popular, a little bit more common, and that's between two clouds. So a positive part of the cloud is closer to the negative part of another cloud, and we see that flash across the sky. That's a CC, a cloud-to-cloud strike. The ones we are most concerned about is the CGs, the cloud-to-grounds. And that is when the attraction of the energy of the Earth is higher than a cloud around the cumulonimbus, and therefore we take that energy to ground. So when we look inside the cloud, it is essentially a battery. We have charge separation with the positive charged ions rising and the negative ones sinking to the bottom because they have an extra atom on them. They are a little bit heavier, and it's literally they sink to the bottom, and that is how we get cloud separation. So that on the image on the right-hand side there, in the middle, you'll see how I reference a cloud to a battery, and you can see how you can have an intercloud strike there or a cloud-to-cloud strike, very simply. When it comes to ground, we see the actual streamer itself zigzagging. The reason it's zigzagging is electricity is just like water. It looks for the path of least resistance, and it's just trying to navigate this area to ground where areas of air are less dense and they're not neutral. So we see these about every 50 meters, 150 feet, we'll see these jagged lines, and that's why it's not a clean direct line to ground. But really, when we talk about the charge, we have the base of the cloud is negative, as I mentioned, and it's looking for that positive energy to mate with. So let's think of it like a magnet. So we have a negative magnet above the Earth, above the asset, and then we have a positive energy in our yacht, in our mast. And what's happening is they're trying to connect together, but they never actually touch. The actual lightning connects about 80 feet in the air. And because what happens is the pull of that negative energy is so strong, it forces what we call a stepped leader, and that's where it actually jumps up out of the asset and mates in midair, if you like. So there's some great images online which we can show you, but the one I really, really like is that lower image that you're looking at now on the screen. And it looks like the lightning's connected to ground. We're seeing that return flash. But when you look around it, it looks like there's some saplings, some trees. They're not. They're actual step leaders that never weren't attractive enough to call the lightning to them. So you can see in this one picture here, we have maybe 5 or 6 other positive charges leaping out the ground. This is quite important because the negative charge mated with the most positive attraction it could see. That doesn't always happen to be the tallest. There's some lovely videos of a small rib in a harbour repeatedly being struck on its engine by lightning, surrounded by masts some 30, 40, 50 meters high. And it's because the positive energy of that engine, or the fault within the engine, was a greater attraction. And that's why I like to reference this as magnets and magnetic attraction. So that's really how lightning comes to ground and how it connects to ground and how it disperses its energy. So when we look at a lightning map, and I've done a global map because I'm very aware that we're talking to captains and seafarers who do transit the globe. This is a lightning intensity map for the last 7 years. And you can see most of it is around land, but it is spilling into the shores. And we are looking more and more at certain patterns forming at sea. And this next slide I'm going to jump to now was annual mean lighting for 7 years. And you see the pattern we've highlighted at the top there, and the amount of strokes per kilometre squared per year. Now, the NASA were looking at this, trying to work out what is forming this pattern, where is this pattern coming from, and when they partnered with Washington University, it was Katrina Burt and Joel Thornton who realised very quickly that this is the pattern is an overlay of shipping lanes. Now, the reason why shipping lanes are creating this pattern is hydrocarbons and static of the water running against the hull. Static charge and hydrocarbons are increasing the attraction of lightning to those areas. So this is something that the DNV standards and Lloyd standards are very wary of at the moment. And it is quite interesting, the fact that a vessel moving through water creates its own energy, even if it's just sailing, purely from wind through the rig and water passing the hull. So I think this is a really relevant slide. It's one that really makes us think about those shipping lanes that we try and avoid. There's another reason to avoid them there, right there. When we look at the technology that we're talking about, it's formulated from in 1918 from the fantastic mind of Nikola Tesla. He essentially said, why would we attract a charge to a Franklin rod like we have done for the last 150, 200 years on top of a church or a building, and then take that charge to the ground? Why would we just not change the characteristics of the atmosphere to prevent lightning from being able to form in the first place? And it was a really fantastic, brilliant mind. So Sertec, Mr. S.R.L, the president of Sertec, found this patent some 30, 35 years ago, formulated it, evolved the technology, and really brought it into a working model. So much so that the Institute of Belgrade, the Nikola Tesla Institute of Belgrade, have actually approved this technology, and they did so with quite stringent testing. We had to conform. The IEC standard for lightning prevention is IEC 62305, and you have to have 335 kilovolts of resistance before you can take the strike to show that you've actually got a lightning prevention system. And we got the most the institute could give was 850 kilovolts, and we still saw zero strike underneath the artificial cloud. I have it on good authority run out to 1,500 kilovolts with the latest testing in Denmark, and we're still at zero strikes. We're nearly 4 times the IEC standard for prevention, which is pretty phenomenal. So how does this technology work? Well, it requires no power. That's the main thing. It's passive. It's a couple of batteries. There's a couple of capacitors at the top of the mast. And what it's doing is it's balancing the field, the electromagnetic field. So we know that we're surrounded by negative energy from that cloud. We talked about that earlier. And we know that our asset is positively charged. In 99% of the cases, this is how it is. And we want to just gently, safely, and continuously allow the static charge in the air around us, or the negative ions, to connect to our positive static charge through this capacitor and drain safely to Earth at between 300 and 600, 30 and 600 milliamps, depending on the amount of saturation in the atmosphere. I mentioned that we're 99% positively charged. If we're negatively charged, there is no attraction from that negative cloud anyway. So it really doesn't matter what our static charge is. If, however, we had a cloud above us that was very heavily charged positively and we were negatively charged, then we'd still be combining this current together continuously, safely, and taking it to ground. So most cases of, pretty much all cases apart from wind turbines, the asset is positively charged. And that's why we reference 99% of the cases. But even if we were negatively charged, absolutely fine, it would still come to ground. So into that in a little more detail about the technology. We were allowing the two charges around the asset to attract to each other safely and harmlessly. Because of the potential difference between the capacitors, that's allowing that to happen. The second capacitor, that lower disc in the image, that's a patent that was formulated on this technology in 2017. And the reason for this is a single capacitor system doesn't really work past a 3-degree heel. It just really, really struggles. So that first capacitor, if you like, is doing all the hard work of protecting the asset. The second capacitor is a bit of a boost when you're healing and when you're moving. So say, come on, guys, this is the way to ground. Without it, we would struggle to be in a position where we can vouch and state that we have got 0 strikes in the field to date. A single capacitor system would struggle, especially with the heel angle of some of these larger boats that we're dealing with now. So just to recap on the whole technology there, is we're taking that the negative charge around us in the atmosphere, we're connecting it to the positive charge from our vessel safely and harmlessly, and continually draining through a 25mm square cable, about the size of my little finger, down the rig into 2 ground plates. And the reason we have 2 ground plates is we've set them fore and aft, port and starboard, below the waterline, and that is to allow us to guarantee that there's always going to be one in contact with the water when you're heeling and pitching in severe weather conditions. So that's really it on the technology side of things. We can go much deeper into that, but I think it's nice to have an overview of how it works, and then I'd like to look at typical installations and also some effects of lightning on rigging as well. And there's always time for 2 questions later, and also I'm sharing my email addresses with you, so we can always answer questions at a later date.
That's great. Thank you. That's a great overview. I'm pretty clear on this. Brian, do you have any questions before we go into the installs? All right, Nick, go ahead. Carry on.
No problem. Touching on one subject before we move on, you'll see an image of 3 different models there: gold, platinum, and diamond. They all take the same mounting bracket. They're just different size capacitors based on the size of the vessel we're protecting, and we do link them together. Her Majesty's Trading Ship, the Royalist, we did recently. It's a Lloyd's approved vessel, and we fitted 2 diamonds to that vessel, so we can link them together like umbrellas, really, if you like. So looking at bracket installation, these are they're not the clearest images, but they really do show what's expected of the installation. The first 3 images are off a Neil 53. I think we've got 9 of those now with our French installer. And so we have a stainless steel tube, which is mounted to the head box, and inside there you'll see the cable running down and then out through the exit slot, securely fastened, and then into the top of the head box and down the conduit. This lower capacitor that I mentioned earlier, this really does have to be the highest metallic point on the vessel. I don't mind if there's GRP antennas around it and higher, but this must be the highest metallic point. We don't want anything poking through the umbrella of protection. And if you do have a whip flex or a stainless steel antenna, that's absolutely fine. You can just cover it in 0.9mm thick heat shrink, seal the top. It will not interfere with your transmission, and therefore we're not looking at a metallic object, and we can discount that as being an issue. The right-hand image, that was fitted to, I believe that was a 52-foot Spirit launched last year. So that just shows a side mount bracket, which was custom made. That's sort of Hallspar's rig. And again, that's all powder coated white just to match the carbon of the rig. So those are some typical installations of a couple of boats that our dealers install with. So we just need three basic numbers really. Your LOA, so your overall waterline length, mast height from the waterline, and the J. And on a motorboat, I'm still going to call it the J. It's to the top of the monkey tree, to the top of the mast. That's all I really need to know to specify the unit, to see what size capacitor we need to protect the vessel. Now, this is quite important because if we recommend a certain size unit for that vessel, we're going to be quite sticky in the mud about making sure it is only that size we supply, because we have to guarantee zero strike for a minimum of 5 years. And we like to work it for more like 10 years. So M5 that we've been protecting since 2017, she had her rigs out in Portofino last year. We sent the unit back to the factory to test the capacitors, and they've confirmed they've got about another 3 years of energy left in them to guarantee protection. So this is ongoing care. We don't just supply to walk away. We do like to look after everybody for the foreseeable, but we are quite stringent on the correct unit for the vessel, and it's all based on these numbers here. Other things that come into play will be whether it's a carbon or aluminium rig, whether we're running PVO rigging or wire rope or rod, but these are just little installation nuances. They don't affect the actual size of the capacitor needed to protect the vessel. Once we have this information, we'll come back to you with a very nice picture of it. Like this is the new Sunreef 140, which was standard fit for boats A, B, and C in Gdansk. So you'll see the zone of protection. We draw it like an umbrella, and I really wish we wouldn't. It's more like a barrel. It's more like a straight line coming out, and then it drops off pretty rapidly. But it's to give this area protection. It's just a nicer way of saying it's a dome. We're guaranteeing the dome as opposed to the upper corners and angles of a barrel. And every vessel inside of this area would be protected, providing their tallest point did not protrude through this line, through this umbrella protection. So moving on to vessels we've worked with, give you a bit of an overview. We do a lot of lagoons, we do a lot of Phantom Bajots, we do Exquisites, we do Wolbies, do Balance, do Neils. So we've got a Neil 53 there in the centre. M5, as I say, we've looked after her for many years. She's back in your neck of the woods now, I believe, as well. Miss Lima, she's back over in the Caribbean at the moment.
All right.
We were standard fit on silent yachts until they went through a few issues and have now reborn again. We're on the options list for Oyster. We're working with Southern Spars on some of their big tri-rig boats, and every single wind wings from BAR on the ships has a diamond device fitted to the top of it. So we're working with some pretty diverse vessels out there. We're also on 8-meter Dutch search and rescue ribs, would you believe? Accreditation wise, we've had RENA for a few years, we've had NATO for many years. What we're really proud of is we're the only system in the world with Lloyd's approval for lightning prevention. And that was awarded to Sertec back in February last year. And it's great that the fact that people like Lloyd's are recognising the technology. They even sent some people into the factory in Paraguay to see the testing as well for themselves. So hopefully that will give your fleet a bit of reassurance about this dark art of preventing lightning. We're about 741 marine assets now, and we're at zero strike still. And there's 11,000 land units around. And when we look at land units, we protect Ford Motor Company. We're with Coca-Cola, Aramco fuel lines. But on boats, we protect Carnival Cruises. We're on Triple M, M5, Kraken 50s, McConaughey 75s, Holland Wolf when they were around. We're with them, with Darman, Artemis electric ferries, Sunreef 140s, 60s, 70s, and 80s. We're working with quite a few boat builders, and this has been pushed really from the, I think from the, not if it's a charter vessel, it's from the charter management side because they want any downtime, but it's also from the awareness of the insurance companies. And it's worthwhile speaking to people like Pantanis if you have this technology fitted and let them know, and what they can do with the excess for high risk areas is quite remarkable, really.
Well, I truly appreciate it. This is a great overview, and thank you for your time. I'm going to open it up now, if it's okay with you, to our members who are on this call and see if they have some questions for you. Let me go to the side-by-side view here. And let's go gallery. So, Brian, you have any questions for Nick?
I do. Thank you, Nick, for your presentation. A couple of questions.
Of course.
You mentioned that catamarans are more vulnerable to lightning strikes.
Yeah.
Could you explain why?
Of course. Great question. So they're about 2.66 more likely, 2.66 times more likely to be hit than a monohull. When we mentioned about the static build-up of charge, we've got two hulls creating static, not one. So our waterline, our actual total waterline, is a lot longer than a monohull. And we've normally got a fairly big rig, not just high, but fairly substantial to take the loads of the cat. So we're getting static from the wind through the rig, and we're getting increased static from the longer waterline length with the water. And the other thing that really, really attracts lightning is solar panels. And catamarans have lots of space for solar panels.
Why do solar panels attract lightning?
Because they're creating energy on the surface, even though they're just taking the lights down, they are warming up, and they are creating an energy which is of a positive attraction. This is something the underwriters of insurance companies are looking at the moment. So
does it make sense if your boat, well, so at night solar panels won't attract anything because is that correct? At night?
Yes. The more active they are, the more attractive they are. They're creating more of an energy around the vessel.
And so during the day, I'm just wondering if you could turn them off, so to speak, at the breaker. There's always a fuse. I have fuse between my solar panels and the MMPT, but that won't help because it's still generating the energy. Or if the
if I'm being completely honest, I would believe that wouldn't help because the panels are creating the energy at source. I would have to clarify that. Most likely one of the engineers in Paraguay, and I will do that, and I'll come back to Dietmar with this as well, and with an answer for you, Brian, because I don't want to just. I want to make sure I give you the right answer, and I just want to check that for you.
So it could be the solution. The mitigation would be prevent generation, cover the solar panels.
It could well be. It could well be that we just need to put an inline switch on those panels, and that could solve it. Yes.
Let's see. You mentioned about having this at the highest point on the mast above everything else. What should be that height difference?
Well, I think in the paperwork we asked for 300 millimeter or foot. Some vessels run it about 2 meters because they're a flagged vessel and they use it on top of the flagpole. But we only need 300 mil or 12 inches above the metallic point. It doesn't have to be extensively higher.
A couple more hopefully quick questions. You mentioned for a sailboat having 2 plates underneath the waterline. If you have a power boat, a trawler, Could you get by with one plate, or would you still recommend two?
Yes and yes is your honest answer. We would recommend two always, because we don't know how much our boat is going to be heeling in the weather. However, if they're deep enough, you can get away with one, most certainly. We've done that with the Pegasus 50 uses a single plate on the very bottom of a swing keel.
Some of these trawlers have what they call as a keel cooler, which is, and I was wondering, would that provide enough surface area to hook up to, so you don't need a separate plate?
I will more than happily look at the electrical drawing of that and come back to you. If you send it through to me, my email address is coming up soon.
Okay.
What we need is 923 centimeters squared surface area. So the Glomex RA 203 pads are really quite small, but because they're the old SSB ground plates, they've got those microsphere balloons. They give us a surface area. So that it's the old grounding, the old SSB ground plates are what we tend to see being used. More than happy to look at it for you. I know the Royalist, we used her anode system because it was so extensive. We just tapped straight into the anodes. We just don't want any AC connected to this at all, because it can build up resistance to this small ongoing drainage current.
And, some people would say you can never prevent a lightning strike. And this is what you're trying to do. And what you want to have is a dual system, which is a prevention if you can, but also if you are struck, a way of mitigating the strike. Do you have any?
Yeah, and that's what you get with a Sertec. So we say we do prevent, well, we prevent the atmosphere building to a condition that allows lightning to form. So when we looked at the image, you'll see there's two capacitors. There's a nylon bush in the middle. We actually refer to that as a fuse, and that's exactly what it is. When we in a laboratory under the artificial cloud, when we take away the ground system so it's ineffective to induce an actual strike, every single time we see that fuse blow. The top capacitor disappears into wherever, but no current goes actually down through the cable. But the unit now is and has been made completely ineffective, but she's still protected the vessel. In that instance, if it's within the 5 years, Sertec would give another unit. We haven't had to do that yet. And if we do everything correctly, like we have been, that will never happen. Oh, well, we calculate it will never happen. But there is a fuse between the two. So that fuse is to protect your boat in the unlikely event of a strike hitting the unit.
Dietmar, I'll let you go to other people.
No problem.
All right. Thanks, Brian. Good questions. Thanks, Nick. David, do you have any questions for Nick? Going down the line. David, we can't hear you. You have been unmuted, but we can't hear you. So maybe your mic is muted or not plugged in, right?
David's with me, Beamer.
Okay, got it.
He's joined me recently, so he's just listening in to join in.
Okay, good. Let's talk with Starfish. Hey, Patrick and Helena, how are you guys doing?
We're doing very well, thank you, sir. Nick, fantastic presentation.
Thank you.
For the installation on top of the mast, okay, I get that. As far as the plates are concerned, are they on, I assume that they are on the outside of the hull?
They are, yes. So the boat doesn't have to be slipped to install these. They are on the outside. On a catamaran, I mean, what vessel do you have, Patrick?
It is it's an Amel Super Maramu 2000. So we have access to the bolts on top of the 12,000 pounds of iron that's the keel of this thing. So is that would that work, or is it a different material?
Only if that iron is exposed and not anti-fouled and painted.
Ah, well, it certainly is. Otherwise, it'd be gone.
Yeah, that's the problem we face. If only if it was that easy. No, she's going to have to be slipped, and we'd just say that the ground plates are fitted. I'd say 4.5 port to starboard. The Glomex RA 20 plates that we supply in all of our boat builders use, they're about 6 inches long by 2 inches wide. They really are quite small. We find catamarans put them on the inner hulls, and obviously monohulls just fit one as far forward as they can and as far aft. But it's just wherever sensible for the boat. But the boat does have to be slipped, unfortunately, and we're gonna have to put some more holes in the hull.
Right, exactly. And what's the material that the plates are made out of, sir?
So they're sintered bronze.
Oh, bronze. Okay.
Yeah. So you can
So
step them if you had a copper slip, a copper anti-fouling, you could put nylon washers behind and step them off.
Okay. Yeah, that's similar to the SSB grounding
Yep.
plates that are
That's
built
exactly
into
what they are. Exactly
Yeah.
what they are. We love those things. Yeah. It's just we need a specific amount of surface area, which also is 923 centimeters squared, which we get from the Glomex plates. But there's other plates around, but they tend to be much bigger. They tend to be the size of a shoebox, really.
Yeah, ours, what we have, it's actually mounted on the skag portion of the rudder, and it's the size of 2 shoeboxes.
Yep. Do you still use those plates for the have you still got an SSB?
No, sir, I don't.
So you could use the plates already fitted.
Yeah, if it was sufficiently large enough. Although I'm not quite sure exactly how you'd get to those plates without taking the without taking the skag apart.
Yeah, there's never an easy solution once you've built, is there?
Yeah. Well, thank you very much, sir. One last question is for a sailboat with a 64-foot mast, 52 feet long. I would imagine that's your middle or smaller unit, and if so, how much for the hardware?
Okay, good question. So you're right. So to let you know, we do a Spirit 52. We've done a few 55-foot monohulls, all with the Gold, which is the smallest unit. But the Oyster 495 has to have the Platinum, and the reason for that is that she's a very tall rig on a 50-footer, and she's quite beamy. So we will run those calcs. I will give you a price in USD. I'll just have to move this around a bit so I can open up. You're looking, I think, about 7,000 US for the smallest one, for the product. And I think it's about 9,500, then 11,500 for the larger one.
Okay.
They're European prices in USD. There's 2 or 3 very good installing dealers around the States. And there's a factory in Panama as well. So there's plenty of options there. Where do you keep your boat?
Currently, it's in San Diego, California.
Lovely. Well, if you want to, I'll put my email up. If you want to get in touch with the details, more than happy to introduce you to a local installer or dealer in your part of the world, and you can talk directly with him if it's of interest. No pressure.
Love to. Thank you very much.
Not so. Nice to talk to you. Thanks for the questions.
Cheers.
All right, good. And then we have Kevin Drum, Magic, and Olena. How are you guys doing? You're in.
Yeah, we good. Thank you. Thank you, Nick. This has been a fantastic presentation. Lots of good info. I think most of my questions have been already answered about, pricing and installation and all that. Do you require like certified installer or you provide instructions to installers? How does that go?
So we do we want to make sure that we're protecting the boat and you safely. So to give you that 5-year warranty which I mentioned, we do require a commissioning report to be done. You can do this yourself. I can show you the report. It's quite extensive. It's lots of photos, really. And there's a few readings on there from a good old multimeter, but also we need an AC clamp meter that will give us an open link and a closed link reading. They're about 700 or 800 euros. So we find that most people tend to have an electrician do the commissioning for them because it's less than pay for the tool.
Right.
So we can give you details of the tool that's needed. The reason we need to see an open link, or an open loop and a closed loop, is these capacitors are connected to the atmosphere, which is touching the water, touching the ground plate, coming back up through the cable. that is our electrical circuit, and
Mhm.
we need a specific kind of tool to actually guarantee that circuit is functional.
Okay. And can you explain again? I didn't quite get that. Your 5-year warranty, what does it cover? Does it cover cost of the unit? Does it cover anything else? How does it work?
What we do is we guarantee protection for 5 years. There is a yearly check where it's just a visual check to make sure there's no damage. And after 5 years, if you are concerned, you can send the unit back to Sertec, or we can uplift it. You send it back for you, and all you're doing is paying for the freight, and they will assess the power or the strength of those capacitors, and they will give you another 3 to 5 years of expected life protection. So, as I said, Mirabella 5, she had it was last year, so her unit's 2017, so it was 7 years old. I went back and they said you're absolutely fine for 3 more years, which means that she's got 10 years worth of guaranteed protection.
Okay, but in an unlikely event of actual strike, if it were to happen, do you refund the costs, or what's the nature of the warranty?
If you were to be hit, we've not seen this yet. We've had zero strike yet. So it's a little bit, we don't want anybody to go first.
Yeah.
But as I said, between those two capacitors, there is that white nylon bush, which is technically a fuse. So if the unit was to receive a strike and that fuse was to blow, we'd ask for the unit to come back. And Sertec have pretty much said they would then donate a new unit and want to know why. But they'd want to see some form of, so there's a maintenance log to be kept. There's yearly readings of the multimeter and the tool, and that would have to be up to date. And if they were all looking good and you received a strike, then they would look very favourably on supplying you another unit.
Okay, one last question. Oftentimes we see, like in our Posse group, there were boats that were not struck directly, but they were nearby strike, and some of their electronics were wiped out, right? By the electromagnetic pulse. What's your confidence, given the dome that you showed, that this may or may not affect the boat?
So the strike would not happen within that dome. And to give you a point of reference, the gold device offers a 25-meter radius protection. So 50 meters in total diameter. So there would, on a smaller vessel, there would be nothing within that 50-meter diameter, 50-meter circle. The platinum device is 55 meters, and the diamond is 120 meters protection.
Right.
So what we're saying is, because we're draining the atmosphere within that barrel, as I mentioned earlier, that dome, no sea strike will happen that close to you. If it's outside of that, well, we're in the luck of the gods, really. But we don't see indirect strike damage when our technology is fitted. You can buy inline filters, I understand, but again, they're fuses and they only work once. What Carnival cruises do, and it's quite a funny story, really. They've put large bronze plates on the waterline, so they sit above and below max and medium minimum waterline, and they connect 95 square mil cable from one through the vessel to the other side. So you can imagine in Singapore last February, when ferry number 1 got struck, the charge came out, hit our Carnival boat into the plate, along the cable, out the other plate, and fried boat number 3. The insurance companies are having an absolute nightmare. That is the only way you can protect your vessel, and that is to take the charge and safely fire it out the other side.
Yeah. Okay. All right. Thank you very much. Very good talk. Thank you.
All right, Nick. Thank you very much, everybody. Thank you for being on this call. Really appreciate it. We're gonna chop this up and make it available to our fleet. And Nick, again, I appreciate it. We'll probably do another one later this year. This is very insightful. Right before lightning season, people will start puckering up, so expect your order book to grow.
Well, I'm here to answer any questions now and in the future. Good catching up with you again.
Thanks so much, guys. See you tomorrow. Bye.
Thank you.
Thank you.
Bye-bye.